Hi, I'm Gunjan, machine learning engineer at AITS. Today I'm going to show you how to bring American Sign Language models to STM devices with the help of our TinyML platform cAInvas and its integrated deepSea compiler, which is optimized for TinyML devices. So let's get started with this notebook where we train our model with high and word sign languages. First, we import all the necessary libraries. Then we plot the graph for acceleration for high and subjections, and then gyroscope for the same. Now we will train the network in PyTorch. So first we do some pre-processing, and then we build the model, which has a parameter count of 5766. Now we will train the model for 150 epochs. As you can see, our accuracy goes till 100. Now we will evaluate the model where our test accuracy is also 100%. Now we will save the model in Onyx format from PyTorch, and then we will compile that Onyx format model with deepSea for board STM32. Now this will deepSea will compile the model and it will save the model as an executable file of size roughly 110 kilobytes. So now for testing that with KVMU, we have two datasets. This is high dataset, this is a test dataset, and this is a sub-test dataset. As the limitation of KVMU, we had to embed these datasets into the code itself. So we have generated two different executables. So let's try out our first executable and see what the result is. Now, as you can see, we are running on a board STM32F4, and the result is 4.85 on index 0 and 0 on the index 1. So the first index identifies if it's a high gesture, and the second index identifies if it's a sub gesture. So if first index is higher, then it means it's a high gesture. Now let's see for another executable that we created. Here on the second index, the number is higher, that is 4.641537. That means it's a sub gesture. So that will be the end of the demo. Thank you so much.